Greetings, Dr. Will here. Welcome back to the serialization of What You Don't Know, Successfully Lead a Software Project Without Tech Expertise. Episode 14, Chapter 6, How Exactly Are We Building It? Analysis and Design, Part 1.
This chapter is a bridge between defining the system's requirements, specifying what the system will do, and the actual doing. This is where the how the system does what it does is decided and validated. Now that a subset of system requirements has been identified and validated, all of the various kinds of requirements are analyzed together. Analysis. The analysis of software requirements is the bridge between the requirements and the design of the software. Given a set of written requirements, they must be understood well enough to proceed with building the right system. The initial set of requirements is discovered during requirements definition. Part of managing the requirements process is using the analysis of the set of requirements to drive the refinement of those requirements. The collection of requirements is refined in part by modeling, and the requirement specifications themselves are adjusted based on the new knowledge. In a large system acquisition, analysis may be done as a separate contractually required step in the development process. Analysis, whether contractually required as a separate documented step or as an informal process, is an activity that makes the developers ready to design the software. Analysis focuses on ensuring the system's functional requirements are handled and usually ignores many, but not all, non-functional requirements. Analysis transforms the requirements into the form that facilitates design. The form and format of the analysis depend on the development or design method followed. A structured design process will create a different analytical model than an object-oriented process. A large enough system will not be comprehensible to any one person. In that case, the system will be partitioned into subsystems that are allocated subsets of the requirements. Each subsystem will be analyzed and the connections between the subsystems specified as interfaces. In very large systems, think government projects with more money than God, the various subsystems may be built by different contractors. When multiple contractors or contractor organizations are involved in the development of a system, gig economy much, the interrelationships among them must be managed carefully. There is an entire key process area of the capability maturity model devoted to subcontractor management. Analysis means to break things apart. Once upon a time, when I was a Ute, I analyzed a mechanical or analog clock with a hammer. So, not like that. Analysis rather in the sense of logically breaking down or decomposing the problem into its constituent parts. Pressman gives 4 fundamental principles of analysis. The first is representing and understanding the problem's information domain, the content, structure, and relationships, and flow of information. The second is developing the necessary models of system data, function, and behavior. Third, partitioning the problem and its models to discover the layered or hierarchical details. Finally, moving from essential information, the logical view, to the implementation detail, the physical view. The goal is to understand the requirements and then efficiently and effectively transform them into a system design, a design that describes how to implement the system. The earliest stages of development should or must establish a robust system architecture that will allow the system to meet its architecturally significant non-functional requirements like performance, scalability, testability, and that sort of thing. This process will create a nearly ideal view of the system to be built. Many of the nitty-gritty details will be left out of the picture. Enough information is created to guide the design of the solution. A danger to avoid here is to fail to preserve the most important analytical information. Some, perhaps much, of the information will be obvious from the resulting design. The most important and impactful analytical information should be retained and managed. Design. Design is completely unnecessary, assuming you don't care how well or even whether the system will actually work. Seriously, a design always exists. It may be only a vague, unarticulated notion in the caffeine-infused mind of one or more of the developers. If there is more than one developer, then it would be useful if that notion were the same in each of their minds, and that it would be retained precisely over time, and somehow imparted to new developers and maintainers of the system, perhaps through a Vulkan mind meld or something similar. The purpose of the design is to integrate all of the known different kinds of requirements, functional and non-functional, into a comprehensive totality. It adapts the results of the analysis to the constraints imposed by all of the non-functional requirements and the implementation environment. There are 2 levels of design: architectural, high level, and detailed, low level. The architectural level establishes the overall structure of the system. The detailed level specifies how each of the critical modules should be built. A detailed design is useful when either the processing or the data are complex enough to warrant a review before actually writing the code. Architectural design. Certain elements specified in the perhaps non-functional requirements and revealed during analysis pose challenges that are difficult, unknown, or of high risk. Maybe as many as 20% to 30% of the use cases may be in the group of architecturally significant cases. These are not necessarily cases visible to the customer end user, but rather cases that may be hidden and essential. They may include difficult performance constraints, a canonical example of correct error handling, or a tricky system startup or shutdown process. Experience is significant here. Architects are not going to be junior developers. Whoever is filling the role of architect should identify at least one use case or scenario within a use case that typifies each of the challenging situations. The design itself should define enough, and only just enough, of the system so that it can be unambiguously implemented. Enough varies from company to company, project team to project team, engineer to engineer. The situation is fluid. The architect, the architecture role, leads and coordinates the technical activities throughout the project. This is not a project manager and not a technical lead, but more of a design visionary. The architect has a broad rather than deep view of the system. The architect establishes the overall structure of each of the architectural views of the system by decomposing the view, grouping its elements, and specifying the interfaces between the major groupings. The architectural views of a system are like the different drawings a building architect prepares: the site plan, floor plans, elevations, and sections, among many others. Consider the care put into building a building, the number of drawings, the engineering effort. But a building is important, unlike software. But if a business depends on or will depend on a software system, then shouldn't adequate care be taken to build it well? And in the case of a SaaS product, the software is the business, and it would seem to be necessary.
That ends Chapter 6. How exactly are we building it? Analysis and Design, Part 1. Join us next time for Episode 15, Part 2 of Chapter 6. That's it for me, for you for now. Be careful out there. Bye.